So a farmer is going to build a rectangular pen along the side of a 50-foot barn. Well, let's say that this is the 50-foot barn. It's 50 feet. And then, because the farmer has 250 feet of fencing, and this is actually going to be a pretty big rectangular area. Perhaps it's for horses or something like that. So we've got, the rectangular pen is going to be built alongside of it. And if I were to only make it this big, there's no way I'm going to use up 250 feet of fencing unless I went 2 feet by 125 feet, which would be a rather strange enclosure. So I'll make it more of a rectangle that's like this. There's the rectangular closure. And now find the dimensions. So that would be this side and this side are the dimensions that we need to find. And since I don't really know what to use for the sides, I'm going to have to use variables. I can just use, let's say, x and y. And now the question is maximize the area. Okay, area is equal to, for a rectangle, that's easy enough, you multiply the two sides. The only thing is this whole section is on quadratic functions, which means that this really should be a function of just x, and in fact have an x squared in it. So we need some other information, and that's where this 250 feet of fencing is going to come in. Well, the 250 feet is really talking about the perimeter. And so that's going to be this length here, which is y, all the way across the bottom, which is x, this side, which is y, and then this side, which stops right here. The farmer doesn't need to use any fencing here because the barn is going to keep the animals contained on that part. So I just need to know what is this length. Well, since this whole side is x, this whole side has to be x. But 50 feet was already taken up by the barn. So this is going to be a total of x and then minus 50. Okay, so now go back to this 250, and if we add up these four sides, that has to be a total of 250. So we've got two y's on the left and the right, plus an x, plus an x minus 50. And all of that needs to equal 250 total. Now what we can do is solve for y. When we get our answer or expression for what y is equal to, we can then take that and substitute over here. So we've got this 50, we could add 50 to both sides. So there's 300 equals 2y plus 2x's. And solving for y is going to be two more steps. Subtract the 2x from both sides. And finally, divide everything by 2. So this will become just negative x plus 150 equals a y. Now we have the expression we need to replace y. So over here, area is equal to x times negative x plus 150. And as I said, this should turn out to be a quadratic function. So it should have x squared. Distributing this x, we have negative x squared and 150x. If I were to graph this, it would look like a parabola. Starting at the origin, it would go up and then back down. And the question asks for, where's the maximum? Well, that's the vertex. One way we could find the vertex is find the two x-intercepts, find the number that's halfway between, and because parabolas are symmetric, that's where the vertex is going to be. So to find x-intercepts, I set this equal to 0, where this is equal to 0 and that's equal to 0 for the area values. And now factor. So we can factor out an x, and it would leave negative x plus 150. Then set each of these equal to 0, so you'd have x equals 0. Setting this one equal to 0 is going to give us the solution that x is equal to 150. So this is at 0 and this is 150. And then halfway in between a 0 and a 150 would be, well, half of 150, which is 75. So the vertex, or the maximum, is going to be at x equals 75. But we're not done yet, because it said to find the dimensions, not just one of them, x, but we also need to find y. Well, if we go back over to our expression on this side, where we had y is equal to, so we have y is equal to negative of what x is, and then plus 150. So y is equal to 75. So it should be split evenly, 75 by 75. So that is the final answer, that it should be 75 feet by 75 feet are the dimensions.